Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. Today we're doing some more electronics fun with Make Electronics, Experiment 11. We'll go to the overhead view here, and I did not set this for the right exposure. That's too much. There we go, we'll try that. So, we got our book out here, and it's got light and sound. So, we got breadboard, hookup wire. We have a box of hookup wire here. We got that. Check. Boom. Done. Okay, so it looks like we got some fluctuation stuff here and some crazy stuff going on here. So 9-volt battery we're going to get from the power supply. We need some resistors. So this time I'm just going to take the stack of resistors out, put it there, and all the caps I'm taking out, because it looks like we need a lot of different values, and the transistors, and the speaker. Where's the speaker at? Speaker must be on the other side. These are pretty handy kits. It's to be sad that it seems like I didn't use all this stuff, and this kit is over. But here is our 8 ohm speaker. 8 ohm. One, preferably 2 inch. Well, this looks like it's 1 inch. So this is what we have to work with. And we need an LED. We're going to do yellow this time. We're going to grab the yellow out of my LED drawer. So we have a yellow LED. So, alright, figure 208 shows you a new circuit. Let's just tamp that down a little bit. Shows you a new circuit here. So if we put it like this here, silicone mat is sticking to the book. Okay, so if we build this like so, we need a 470k resistor here. So we're just gonna add 3 transistors. Well, all 6 transistors will be used. So we got a really weird looking 470 ohm resistor, and that is going to go, we'll put it in 5 to 10, so we have a reference there. No, that's not 470, that is 47, what is it, red, 4720 is 4.7k, so that one's a 4.7k. That was my mistake. So this one is a 4.7k. I don't believe we used a 4.7k yet. There we go, 4.7k here. There we go, that's the right resistor. We're going to bend that down. I'm going to plug that into 5 and 10. And we'll go ahead and put our jumper from the power rail to that guy. That's what it says. Alright, so we got that part right here. Let's... kind of curious what these little capacitors are. Does it? Yeah, here we go. Here's a better. Well, it gives me the schematic drawing here on this side with the actual values. Let's get all these components over here. So there we go. Now we can to our 470K resistor. So there we go. So we're going to come in here, 470K. And that one is going to go roughly 2 short of 10. So we'll put that in position 8 right there. Now we need a 3.3 picofarad. No, that's 0.33. 1. 0.1. There's a 33. Micro, 100 micro. I don't see. Up 3.3. Found it. Now it's strange that these are electrolytic capacitors, but they're not shown as electrolytics, or with a, yeah, they're not shown as electrolytics. So I am going to grab some 3.3s out of my, some non-electrolytic tantalums, not tantalums, ceramic capacitors. There's a name for these. So 3.3. Got 2.2, but no 3.3. I think 330 picofarad is 3.3 microfarad. No. Let's look that up real quick. Okay, so I don't even see that they have a 3.3 microfarad capacitor. You got 1 microfarad, not 3.3. That's just rude. Well, this video is turning into a nightmare. Yeah, that's definitely not a conversion. Alright, so I don't have a 3.3 microfarad capacitor here. Let me check my other group of capacitors from eProject. Oh, never mind. Found them. Oh, right here in my little tantalums. So this is 3.3 is right here. 3.3. 3.3. Yep. Okay, so these are polarized, so the long leg is positive. So see, this is what doesn't make sense, because I need a non-polarized capacitor. Because both sides are positive. Okay, so these aren't going to work. Okay, let's just look through this. 1 microfarad, 0.33, 0.1. So we have a 3.3, but again, it is a electrolytic, and it is going across the positive rail. Could put it in a more positive, but let's just check the box here. .3, and it's electrolytic. So, yeah, it's electrolytic. Alright, I'm going to pause here and figure out what to do. I don't know if this is a misprint or what, because it's going across to power. It's going to positive. I guess it's going from positive to ground here. I don't really want to blow up a capacitor, so I guess the tantalum is less likely to blow up. So let's put let's go this way. There like that, and then we'll have to move this leg like that. And then yeah, this just doesn't. I'm gonna get back to you on this because I'm confused. It's early. I'm gonna figure this out. Okay, it appears after further investigation that it does need to be a non-polarized capacitor, because as you see here in this snapshot 1, the power is going to the left side of C1 and ground is going to the left side of C2. So you would think, oh, I'll just put it in that way, but if you continue with how the circuit is running in the step-by-step diagnosis, the snapshot 2 in the second part of the circuit, how it works is this side is now ground, and then this side is positive. And then if you go to snapshot 3, this side's positive ground, and this is ground in relationship to this transistor ground. So, and then now this side's ground, but this is disconnected. So I'm going to say it definitely has to be a non-polarized capacitor. So what I'm going to do is, I don't have a 3.3. So I'm going to use a 4. Because 4 is closer than a 2. So I have a 4. I have a 4. No, I have a 4.7. So I'm going to use a 2.2. Yeah, I'm going to use a 2.2. 2.2. Just an odd size. I don't have that capacitor. I probably have it in surface mount though. Okay, so just put this back. Organize that later. So let's get back our circuit here. So let's. This is just an RC circuit, so it's not going to have that much effect on. It's just going to adjust the timing a little bit. Okay, so if we look at that, that's that right there. So now we need a transistor here. Let's turn that back a little bit. We need our transistor here. And we need a 100K resistor. 1K, 470. Okay, 470, 10K. I'm starting to wonder if I left things in the box because I don't have a 100K resistor out here. Okay, so let's. This kit is not as complete as I had hoped. There's 100K right here. So 100K resistor from this side of the. And we're going to come to 15 here. To 15. So that's that. And then we need another transistor. And the book will, you know, you guys got to get the book and go into detail of why this is working like this. But this is going to the base of this transistor. So that's going to the base of that transistor. Let's hook up a jumper here for power to the emitter. It's a little short, but so now we need a 1K resistor. I'll have my fill with this kit, but I'm going to finish the book, guys. This has just been a bumbling storm of mess. Okay, so we need a 1K to go from this to that right there, and then we'll put our LED in positive lead to negative. Positive lead to negative. I mean, positive lead to the resistor and negative lead cathode to the negative side. And then we need a jumper that comes from the emitter of the emitter could be. No, this is the collector of this transistor here. We're going from the collector to the collector of another transistor. Another transistor. To the collector of another transistor. Okay, and then that base of that transistor is going to go to this junction here with all this. The base, base of that transistor is going to go to this allotted group here. Okay, still the wrong size. Okay, so from here to there. And, wow, why can't I get this right? This is just sad. Okay, from there to there, that's that. And then, so we have this whole side hooked up. Now we need to put this emitter to ground. Emitter to ground. And then we need our capacitor to go there. And then we need our 4.7K resistor. Resistor to go to 5 and 10, and then the 470. Will go to same point. Donovan, I'm in a video.
Huh?
I'm doing a video.
What?
I'm doing a video.
I know.
So you got to keep it down, please.
Oh, okay, sorry.
Thank you, buddy.
And now it's stopping.
Alright, and then we just need a power line. Power line here. Okay, so that is, oh no, we still need a hookup from this output to the base of that transistor. So there we go. So that should be good to go. That should be hooked up. Okay. Let's see if we can turn it on. Alright, let's check this out here. Let's get some power on this rail, on these rails, and see what happens. And 9.5 volts, only run 9. So I don't think I'm gonna hook up the sound part of this. That may be a bonus video. Let's turn this on, and it flashed once. It's drawing, no, it's not drawing any kind of current, so how does it start? It doesn't do what I wanted. It's not doing it here. So let's just check our circuit here. It did pulse momentarily. So we have power into there. Appears we have everything hooked up correctly. Base to base, base to base. Let me turn power off and turn it back on again. See, it flashes once and then it's done. It's drawing 20 milliamps. 180 milliwatts. Nothing seems to be shorted or getting. All I can think of is it's those capacitors. They're like not discharging properly or not charging properly. It's the only thing I can think of. Everything seems to be hooked up correctly. Well, I'm going to call this an epic fail. So maybe I'll do a follow-up video of this working, because I'm not going to waste any more time on this. This is like a 40-minute video. I'm still going to upload it, but this was an epic fail. Sorry, guys.